Hi, everybody. So today I'll be giving a quick talk about building derivative products and financial products in Hyperliquid. And more specifically, I'll be talking about the precompiled contracts and the unique opportunities that arise due to the dual execution of the Hyperliquid chain and the Hypercore and Hyper-EVM synergy. First, a quick introduction about myself. So my name is Aleksa. I work as a researcher at Decenter R&D. It's the birthplace of DeFi Saver, and now also of Perpflow. Perpflow is a yield platform on Hyperliquid, which I will get into more in the later part of my presentation. Okay, so first, for those of you that are maybe not that much familiar with what Hyperliquid is, Hyperliquid is a completely separate Layer 1 blockchain that is built and optimized for derivatives trading. It operates under the Hyper-BFT consensus mechanism, and it is highly performant. It has a throughput of close to 200,000 orders per second, and with a block time of 200 milliseconds. Its state execution is split into two components. So the Hypercore component is the component that first launched, and it's the one that has the 200 millisecond block and you have a throughput of 200,000 orders per second. And on it, you trade with the derivatives, the perps, the spot market. It has the CLOB, the central limit order book, and it's highly performant and optimized for perps trading. Now, the second execution layer that, as I said, operates under the same consensus mechanism is the Hyper-EVM, and it has all the familiar things that all EVM systems have. You can deploy smart contracts, write it in Solidity, and so on. Now, what is the main issue with the dual execution system? And that is, how do you handle the communication between the Hypercore execution layer and Hyper-EVM execution layer? And now, how Hyperliquid does this is through the precompiles. Now, precompiled contracts are not something new. They already exist on Ethereum, and on Ethereum they're used for operations that are constantly needed and that are gas intensive. So precompiled contracts are gas efficient functions embedded directly into Ethereum on client level, meaning that these are not Solidity smart contracts compiled right in the EVM. They are written in Go on client level. And you can access these functions and these contracts at fixed addresses between 0x01 to 0x09. Examples of these functions for Ethereum are elliptic curve functions, the SHA-256 encryption, modular exponentiation, and so on. All the functions that are constantly being used in Ethereum. So Hyperliquid uses the precompiled contracts also, but it serves a different purpose in the Hyperliquid ecosystem. In the Hyperliquid ecosystem, it is used to connect and bridge Hyper-EVM with Hypercore. So you want to have the familiar EVM atomic smart contract interface while also having access to the highly performant order books that Hypercore offers and the deep liquidity that it comes with. So how does Hyperliquid does this? It has two systems of contracts, the read precompiles and the write precompiles. The read precompile contracts allow you to query the current state of Hypercore and to read any of the information from Hypercore. So this could be reading user balances, reading which positions users have in certain perpetuals, the oracle prices of the perpetuals, the order book mid-price of the given market, and so on. And as you can see from the code, you just call a precompile address, you give it the user's address and the token address, and it will return to you the balance for the token of the user. The other system of precompiled contracts are the write precompiles. And the write precompiles allow you to execute actions on Hypercore. Now, I didn't mention it, read precompiles are currently live on mainnet, and the write precompiles are still in the testnet phase. But the write precompiles are the ones that are the most anticipated because they will allow you to execute actions on Hypercore from Hyper-EVM. What this could be is sending orders to the order book, transferring funds from one L1 account to another, delegating stake to validators in the Hyper-BFT consensus mechanism, and so on. Now, how the write precompiles work are you call a precompiled contract, it emits an event that the validators that operate the Hyperliquid L1 listen to, and they include your order in the next L1 block. So here you have an example of sending an IOC order, so that's just an immediate or cancel order to the order book. You select which perp you want to trade, what is the direction you want to trade in, the limit price and size. The send token delegate is the example of giving a certain validator address, a certain amount of hype to stake in the HyperBFT consensus. Now, I want to give you 4 examples here today of what unique things you can build with this. And I'm not sure what happened to the text here. What? Okay, so forget about the text, something happened. I'll talk. So the first example is the precompiles and the ERC20 token example. So what you can do with the dual chain architecture is you can deploy a familiar ERC20 token on HyperEVM, and at the same time, you can deploy a spot market, a spot order book on HyperCore. It's done for a Dutch auction. You buy a ticker, right, and you can deploy any spot market on the L1. And through the precompiles, you can connect these 2 markets. So you can make this token one-to-one fungible on these 2 chains. So when you send to a certain precompile address one of these tokens, you will get it minted immediately on HyperEVM and vice versa. What this creates, right, is you can have all the DeFi functionality on HyperEVM with the ERC20 token standard, plus the deep liquidity and performance that Hyperliquid L1 offers to you. A second example is the decentralized staking. So the current stake... Sorry? You'll fix the slides. Okay. How currently staking works on Hyperliquid is staked hype. You send it into a staking contract, right? But the staking contract has to send it to an EOA address on L1, which then delegates the stake to validators, right? But with this token delegate function, you can have it all happen from a smart contract, right? And that's what the Kinetic Hype team is currently doing. So you just put it into a staking contract, and it calls the delegate function on the right precompile and delegates the stake to HyperCore validator that you choose. Another example of using the precompiles is the... Yeah, should I wait for the presentation? Or? Okay, I'll wait. Yeah, it's okay. Okay, great. Okay, so where was I? Yeah, the precompiles. So here's the third interesting example of what you can use the precompiles for, is to execute liquidations in lending or CDP protocols. So imagine you have a classic lending protocol on EVM, and you place XYZ collateral to borrow ABC token. Now, the lending pool with the precompiles, it can execute automatic liquidations. So what it can do is it can do it all in this decentralized way by using the read precompiles to read the prices from the order books, calculating if your position has reached the liquidation threshold, and then using the write precompiles to access the deep liquidity of the order books on HyperCore and sell the collateral asset, thereby performing a fully on-chain liquidation. Okay, and the fourth final example I want to give to you is an example of how we plan to change our product to use the right precompiles and to create a vault for our users. So let me first give you a quick introduction of what we do at Perpflow. So Perpflow currently is a non-custodial, one-click execution dashboard for running the funding fee strategy and on Hyperliquid. And what the funding fee strategy is essentially you're shorting the perpetual contract on one side and buying the exact same size of the token. And essentially you're creating a delta neutral position, meaning that if you open the funding strategy on Hype token, if Hype goes up by $1, you will lose the same amount on the short perpetual contract, and you will win the same amount on the spot side, right? So the only exposure you have no exposure to the price of the underlying asset, you only have exposure to the funding fee. And funding fee is the mechanism that keeps the perpetual price in line with the spot price. And funding fees are there to reduce the basis, right, the spread. So when the demand pressure is higher in the perpetual markets, the funding fee gets wider. When it is less than in the spot market, it goes on the other side. And a funding fee is accrued every hour, longs pay shorts if the pressure is bigger on the perp markets, and shorts pay longs if the pressure is bigger on the spot demand side. Now, empirically looking, we looked at the data for the past 5 years, and due to the lack of liquidity on the short side of the order book, the funding fee, when annualized, has always been returning close to 15 to 20% on liquid perpetuals to the short side of the traders. So the protocol has to incentivize the short traders by funding fee and therefore maintaining the peg. Now, how we do this strategy currently, we have a non-custodial setup. We are a front-end wrapper on Hyperliquid. We just execute the transactions in your wallet. The problem with this is you have to monitor the liquidation part of the perp. Now, to automate this, currently you would have to have a centralized solution where the money goes to an EOA, it trades, and it sends the money back to the user when he wants to withdraw it. Because currently, without the right precompiles, you cannot execute transactions on L1 from HyperEVM. But with the release of right precompiles, this becomes possible. How? So this is the architecture. What we plan to do is to deploy a classic ERC 4626 vault on HyperEVM, where users would just deposit the collateral asset and get a share of our vault. In this case, the collateral asset is the USDT. And through the right precompiles, this vault will execute the transactions on L1, creating this delta neutral position. So what this means is you put in USDT, and we take this USDT, and we execute two actions with the right precompiles. One is we buy Hype for half the money, or half the notional size, and at the same time, we short the perpetual on Hype, right? And we create this delta neutral position, and the only exposure we have is the funding fee. If the funding fee is on the side of the short traders, meaning that longs pay shorts, we earn money. If it is the other case, we lose money. But empirically speaking, the funding fees have always been on the side of the short traders. Okay, so these were the 4 examples. There are many more examples, and we'll see what happens once the right precompiles will launch. But for the end, I would like to talk about the problems and the possible solutions to these problems that arise with the precompiled contract. The main problem is that if you look, because this is a dual block system, you have the EVM blocks, you have the L1 blocks, and the L1 blocks go much faster than the EVM blocks currently. What you do is when you use the read precompiles, you read data from the previous block on L1, and when you write the data, when you want to issue orders to L1, you write the data to the next block from EVM, right? Now, this is a problem because this creates, it's not fully atomic, right? And as we saw when I was talking about the right precompiles, you just emit an event, and the validators include your transaction in the next block of L1. Now, this doesn't guarantee to you that the trade has been executed on Hypercore, right? Because it only guarantees you that the event has been emitted. So you would need to check in the next block. An off-chain component would need to check in the next block if the transaction is really executed and update the contract on it. Now, this can become really cumbersome and difficult maybe. So we see that this can be probably done in a separate solution, but we'll see. Yeah, I think that's it. Thank you all for listening. This is the QR code to Perpflow. Yeah, any questions? Any questions? Yeah.
Yeah, thanks for a great presentation. I just wanted to ask if there is some estimated time of arrival of those write precompiles.
Yeah, so the team hasn't given us any official stats, but I think in the next couple of months is the estimated time, but no official information.
So how do you think the price when you read from the before and you write it later? Like, do you use like some kind of slippage, or how do you define it?
You're asking me if I'm reading from the last block the price, how do I know which limit price to use? Yeah, so the blocks are extremely fast, so it can't change that much, but that's why the write precompiles don't have like, you send immediate or cancel orders. What that means is you just say the limit price, and if it gets executed on it, it executed. If not, it's canceled. So that's how it works. Yeah, but it is a problem, that's the last thing, that's the thing I was talking about, this latency. Okay, thank you guys.